Hello everyone. Today's problem was submitted by a viewer. It says, let y be equal to x squared plus x sine theta plus 1 divided by x squared plus x cosine theta plus 1. Given that x is real, show that y cos theta minus sine theta squared is greater than or equal to 4y minus 1 squared. Deduce that y squared plus 1 is greater than or equal to 4y minus 1 squared, and hence that 4 minus root 7 over 3 is less than or equal to y is less than or equal to 4 plus root 7 over 3. Okay. So this first, how do we show this first inequality? Let's write down what we're given. Y is equal to x squared plus x sine theta plus 1 divided by x squared plus x cosine theta plus 1. Show that y cosine theta minus sine theta squared is greater than or equal to 4 times y minus 1 squared. I mean, part of me wants to maximize this as a function of x and see what happens. Or maximize or minimize. Maybe maximize and or minimize as a function of x and a function of theta. But it's interesting to see that we get something quadratic in y coming out. I don't know where the quadratic with respect to y is coming from. And I don't even know exactly why minimizing and maximizing with respect to x could potentially be something of interest. Maybe we just compute that. Given that y is equal to that, compute that quantity, also compute that quantity, and see what we get. You know, I also notice the 4 is also something that kind of throws me off. I guess if we let theta be equal to pi over 4. Okay. Y cosine theta minus sine theta squared. If theta is equal to pi over 4, then cosine theta is equal to sine theta is equal to 1 over root 2. So then I have y cosine theta minus sine theta squared is equal to y minus 1 over 2. And that should be squared. That's if theta is equal to pi over 4. Kind of looks a little bit like what we're talking about, but not really. Okay. F of theta is equal to y cosine theta minus sine theta squared. And so x is fixed. Maybe I should call this f of x and theta. No, because on the right hand side y has a theta in it. So x is fixed. F of theta is equal to this, but let's make it clear that y is a function of theta. So what I'm going to do is minimize this and hope that the minimum is 4 times y minus 1 squared. Okay. Let's minimize f. So f prime of theta is equal to 2 y of theta cosine theta minus sine theta times the derivative of the inside, which is y prime of theta cosine theta minus y theta sine theta minus cosine theta. And that should be equal to 0. So either this is equal to 0, in which case, of course, we have minimized that. Or we have y prime of theta cosine of theta minus y of theta sine of theta minus cosine of theta is equal to 0. So the part I really don't want to go through with here is I have to take a derivative now of y of this function y. Maybe it won't be that bad. Okay, let's write out what the function y is exactly. Y of theta is okay, so y prime, derive the top times the bottom, minus derivative of the bottom times the top, divided by the bottom squared. Let's expand this. Y prime of theta is equal to x cubed cosine theta plus x squared cosine squared theta plus x cosine theta plus x cubed sine theta plus x squared sine squared theta plus x sine theta. Okay. And we have some simplification here for sure. X cubed plus x cosine theta plus sine theta plus x squared divided by, oh, I need the denominator to be squared. So that's y prime, and we still need to work out, we still need to substitute the rest of this and set it equal to 0. This is really messy. This can't possibly be the simplest way of figuring this out. Oh, wait a minute. The right-hand side of the inequality I'm trying to show, this still depends on theta. So what I'm doing here is not, it's really not going to work. It's like it's not even, it doesn't even make sense. I mean, does it make sense to just expand the entire expression? So I have y cosine theta minus sine theta is equal to x squared cosine theta minus sine theta plus x. No, actually the x terms cancel. I have plus cosine theta minus sine theta divided by x squared plus x cosine theta plus 1. So y cosine theta minus sine theta is equal to x squared plus 1 times cosine theta minus sine theta divided by x squared plus x cosine theta plus 1. Come back to that in a second. I want to compute what y minus 1 is equal to. Y minus 1 is so I get the following: y cosine theta minus sine theta. Wait, let's let f of theta be equal to sine theta minus cosine theta over x squared plus x cosine theta plus 1. Then this is equal to x squared plus 1 times negative f and y minus 1 is equal to f f of theta times x. So y cosine theta minus sine theta squared is equal to f squared theta x squared plus 1 squared, and y minus 1 squared is equal to f squared theta x squared. So let's define a new function, g of x, which is x squared plus 1 over x all squared. And I want to try and minimize this. So let's take a derivative. G prime of x is, and I don't even really need the squared part, but we'll continue with that. 2 x squared plus 1 over x times the derivative of the top, 2x times the bottom, minus the derivative of the bottom times the top, divided by the bottom squared. So when this is equal to 0, that can't be equal to 0. So I have 2x squared minus x squared plus 1 is equal to 0. I have x squared minus 1 equals 0. So x is equal to plus or minus 1. Okay. When x is equal to plus or minus 1, this implies g of x is equal to 4. That's where the 4 is coming from. So the minimum value of g is 4. The minimum of g of x is equal to 4. So if I now look at my original expressions here, these ones, if I take a ratio of these, for example, y cosine theta minus sine theta squared divided by y minus 1 squared. This is equal to g of x because the f of thetas cancel. Okay, so this is g of x. And the minimum value of g of x is 4. So this is always greater than or equal to 4. And this gives us what we want. Y cosine theta minus sine theta squared greater than or equal to 4 times y minus 1 squared. Yeah, I don't, maybe there's a more direct way of doing that first part. But this was, I don't know. And I got a little bit lucky that just substituting, just computing what that thing is and computing what that thing is, I recognized that they both had this cosine theta minus sine theta inside them. And then it's kind of natural to take a ratio. Okay, so now we want to deduce from this. So now we need to show that y squared plus 1 is greater than or equal to 4 y minus 1 squared. Okay, well, Now it looks like we should do something with theta. I mean, if I expand here, I get y squared cosine squared theta minus 2 sine theta, 2y sine theta cos theta plus sine squared theta is greater than or equal to 4 y minus 1 squared. So if I just make things on the left-hand side bigger, I can't go wrong. You know, if I just replace cosine squared and sine squared, just replace those with 1, then the left-hand side only gets bigger. But the 2y times sine theta cos theta, I mean, that could be negative. I almost want to do the same thing where I just maximize this quantity with respect to theta. Am I allowed to just like think of y as being any fixed number though? Because it does depend on theta. I guess so. Why not? Like y is if I maximize this, if I think of y as being fixed and maximize this with respect to theta and show that this is always true, then it will in fact also be true for the value of y which corresponds to this value of theta. Just realize I did show that this function g is a minimum, right? Not a maximum. Well, the maximum, we can let x go to 0. I guess maybe there needs to be a little bit more detail in here with second derivatives and so on, but I'm going to ignore that. I don't think that this is the way to go. Y cos theta minus sine theta squared. What happens if I factor out cosine squared? Yeah. I mean, I know how to do the last part of this, showing the bounds on y between these two, 4 minus root 7 over 3 and so on. It's a quadratic expression and it's positive. So just draw a parabola and find for which values of y the parabola is positive. or negative, whatever. But how... I mean, I have certainly y squared minus 2y sine theta cosine theta plus 1 is greater than or equal to 4 y minus 1 squared. But if this whole thing is positive, including the negative sign, then I can't just get rid of that. Is it true that is y always positive? Based on the expression, like it looks like it probably is. I think y is, it's easy to see that y is always positive based on the expression that's given by. Break it up into cases when x is greater than 1 or less than 1 in absolute value. So y is always positive. But then this is equal to y squared minus y times sine of 2 theta plus 1. But sine of 2 theta can be negative. So this whole thing could be positive, so I can't just drop that term. Well, I showed earlier that this is equal to f squared, oh, it's this thing. Squared times x squared plus 1 squared. I just don't see how one thing follows from the previous. Y cosine theta minus sine theta squared. How does this compare to y squared plus 1? Is there an identity that I just don't know about here? Okay, I'm going to skip this part for now. Move on to the next part. We're going to assume that y squared plus 1 is greater than or equal to 4 times y minus 1 squared. Let's just expand this. Y squared plus 1 is greater than or equal to 4. Y squared minus 2y plus 1. Y squared plus 1 is greater than or equal to 4y squared minus 8y plus 4. So I have 0 is greater than or equal to 3y squared minus 8y plus 3. Okay, so I have a parabola which opens upwards because the coefficient is positive. Okay, and we want to find all values of y where this is true. So we just have to find the roots of this parabola, and we know that y will be in between that. So the roots, let's call it y star. Eight plus or minus 64 minus 36 over 6. (64 minus 36) 28. So y star is equal to, divide these by 2, 4 plus or minus root 7 over 3 is exactly what we're right? So y must be between 4 minus root 7 over 3 and 4 plus root 7 over 3, which is, exactly what we're asked. I don't know how we found this last, how we're supposed to find this last thing. Right, I still don't know how to show this, but if you start with this, if you assume that this is true, then you can easily show that y must be between these two values. Very easy. Okay, so there's another follow-up part to this question. What does it say? In the case that y is equal to 4 plus root 7 over 3, show that the square root of y squared plus 1 is equal to 2 times y minus 1. Find the corresponding values of x and tan theta. So I don't think this is terribly difficult at all. I mean, just let y be equal to this value and sub it in on both sides of this equation. So I'm gonna skip. I'm not gonna go through this one. But so if we let y be equal to 4 plus root 7 over 3, we're asked to show that y squared plus 1 square root is equal to 2 y minus 1. Okay, just substitute into both sides, and this should work out. Well, square both sides first, substitute in. You'll have to work through some stuff. You'll have radicals, but fine. You should be able to get that they're equal if this statement is in fact true. And then it says find the corresponding values of x and tan theta. So I think showing this must come from some kind of optimization with respect to theta. And if all of these inequalities are actually equalities everywhere, then it just means that all these optimized functions, we've attained the optimizer. So I showed that the minimum value of g is 4, and that happens when x is equal to plus or minus 1. So the corresponding value of x for this final thing is almost certainly going to be plus or minus 1. And I don't know why, if I'm having some kind of brain lag or something like that, but I assume that getting from here to here is maybe you can do some kind of maximization with respect to theta, and then again just choose if the bound is tight, if there's or sharp, whatever the correct word is, then just find the value of theta which actually gives that minimum or maximum value, and that'll be the corresponding value of theta, or tan theta at least, which gives you what you need. But I don't know why I'm not able to just see how to get from one to the next. Yeah, but I'm going to call it an end here. I don't want this video to go on forever. If I think of a way of approaching this question before actually posting the video, then I'll write something down in the description. So be sure to check that. Thanks for watching.